multi-enzyme complex catalyzes decarboxylation of pyruvate and the transfer of its acetyl group to coenzyme A, yielding acetyl-CoA. The pyruvate dehydrogenase multi-enzyme complex contains three separate enzymes, E1, E2, and E3. Enzyme E1 decarboxylates pyruvate. Its thiamine pyrophosphate, TPP, cofactor, reacts with pyruvate to form a hydroxyethyl intermediate, thereby releasing carbon dioxide. The hydroxyethyl group nucleophilically attacks the cyclic disulfide of the lipoamide prosthetic group of enzyme E2, and TPP is eliminated. In this process, the hydroxyethyl carbanion is oxidized to an acetyl group, as the disulfide is reduced to yield dihydrolipoamide. E2 then catalyzes the transfer of the acetyl group to coenzyme A to yield acetyl-CoA. Enzyme E3 of the complex then functions to oxidize the dihydrolipoamide of E2 back to lipoamide with the concomitant reduction of NAD to NADH. Citrate synthase catalyzes the condensation of acetyl-CoA and oxaloacetate to form citral-CoA, which is then hydrolyzed to citrate and CoA. Catalyzes the dehydration of citrate to form the intermediate cis-iconotate, followed by the hydration of cis-iconotate to form isocitrate. Hydrogenase catalyzes the oxidative decarboxylation of isocitrate to alpha-ketoglutarate in a reaction that reduces NAD to NADH. Glutarate dehydrogenase multi-enzyme complex catalyzes the oxidative decarboxylation of alpha-ketoglutarate to form succinyl-CoA and the reduction of NAD to NADH, a series of reactions analogous to those carried out by the pyruvate dehydrogenase multi-enzyme complex. Note that we now have, in effect, lost both carbon atoms in the incoming acetyl-CoA as carbon dioxide, although these carbons actually came from the oxaloacetate in reaction 1, rather than the incoming acetyl-CoA. The cleavage of succinyl-CoA to the synthesis of a nucleoside triphosphate. Succinyl-CoA first reacts with inorganic phosphate to form succinyl phosphate and free coenzyme A. The phosphoryl group is then transferred from succinyl phosphate to a histidine residue of the enzyme, releasing succinate. Finally, the phosphoryl group on the enzyme is transferred to a nucleoside diphosphate to form the corresponding nucleoside triphosphate. GTP is usually synthesized by mammalian enzymes. ATP is formed by the corresponding enzyme in plants and bacteria, in a reaction that has a carbanion transition state. Hydrogenase catalyzes the oxidation of malate to oxaloacetate with the concomitant reduction of NAD to NADH.